In this video, I am going to explain Anova. What is Anova? Anova is the analysis of variance, is a statistical method used to analyze the differences between means of two or more groups or treatment. It is used to determine whether there are significant differences between the means of the groups being compared or if the differences are due to chance. The basic idea behind Anova is to compare the variance between groups to the variance within the groups. If the variance between groups is significantly greater than the variance within the groups, it suggests that groups are different from one another and the differences are not due to chance. Anova is commonly used in many fields, including psychology, medicine, biology, and business. It is often used in experimental designs to determine if a treatment or an intervention has a significant effect on the outcome variable. There are several types of Anova, including one-way Anova, two-way Anova, factorial Anova, and repeated measures Anova, each designed for different research designs and situations. Anova is a commonly used statistical method in many fields and research designs, and some of its applications include experimental research. Anova is commonly used in experimental research designs to compare the means of multiple groups or treatment. Clinical trials. Anova can be used to compare the efficiency of different treatments or medications in clinical trials. So manufacturing. Anova can be used to compare the mean performance of products produced by different machines or processes. Education. Anova can be used to evaluate the effectiveness of different teaching methods or programs. Market research. Anova can be used to evaluate the effectiveness of different advertising campaigns or marketing strategies. Psychology and social sciences. Anova can be used to compare the means of different groups in surveys or experiments related to psychology and social science. Biology and genetics. Anova can be used to compare the means of different groups in experiments related to biology and genetics, such as studying the effects of different treatments on cell growth or gene expression. Let us take one example. One example of numerical problem that can be solved by Anova is comparing the mean scores of three different groups of students on a standardized test. Suppose a researcher wants to know if there is a significant difference in the difference in the mean scores of students who received no intervention, students who received a tutoring intervention, and students who received a study skills intervention. To solve this problem using Anova, the researcher would first collect data on the test scores of each group of students. They would then calculate the mean score for each group and use Anova to test whether there is a significant difference between the means are there or not. If the Anova test shows a significant difference between the means, the researcher could then perform additional tests such as pairwise comparisons to determine which groups have significantly different mean scores. These tests could help the researcher identify which interventions were most effective in improving test scores. Example of how to perform Anova in R programming. Using the R programming, you can perform the Anova test. Suppose we have three groups A, B, and C, and we want to compare their mean values. Here is an example code. Let us see that example code. First, group A, that tends to column of 10, 12, 15, 18, 20, and group underscore B tends to column of 8, 11, 14, 16, 19. Group underscore C tends to column of 9, 13, 16, 17, 21. So these three groups data is given as an input to the R programming software. Then you can take the combined data into the single data frame. Then use this function data tends to data dot frame value. Value is equal to column of group underscore A and group underscore B, group underscore C, that whatever the above values are assigned. Then the group is equal to representation of the column A, column B, column C. Each column A, B, C will come on the same column. Each is a category, each is a quantity of 5. That is, each is equal to 5 is there. See that values of group A, B, C is 5 values here. That is here mentioned, each is equal to 5. Now let us see that how the data is stored. Let us just verify in the software after giving this code in our programming. Now just I verify the data, just I type out the data and enter, then this value will be displayed like this. Okay, that is the value, the group. Okay, the value is 10, 12, 15, 18, 20. That is all A is coming under that B and C. So that is previous command is used to form these columns like this. Okay, all A, B, C all comes under the same column. All comes under the same column. Okay, now here we are comparing the value and group. Value and group. Value is all the values, that is the 12, 15, 18 to 8, 11 like this. And group is whether it belongs to which group, A group or B group or C group. Now run the Anova. For that you have to use this function. Model tends to AOV. Anova is AOV value the relation to the group. Value relation to the group. That is we taken which data is data already stored in the data frame. That data is equal to data. So from that data it will relation of value and group. Now let us verify that what stored under the model. Just type the model and enter. Then these results will be obtained. Call. So that function is called AOV. Formula is equal to value versus group. The data file. The terms. Okay. The sum of the squares. That's 7.6. Okay. And residuals 222. And degree of freedom is 2 and 12. The residual standard error is obtained 4.301163. Estimated effects may be unbalanced. This is the data is obtained from the model, which is using that data file, data.frame file. Like that, using the R programming, we can verify the data. Okay, you can find out what degree of the freedom, what is the sum of the squares, what group, which group, and residuals. All these things we can verify directly in the R programming. So now let us will see the summary of this model. Just model type that values. Now we can see that what is the summary of the model. Then this is the summary of the model. That is the group degree of freedom is 2 and sum of the squares is 7.6 and mean square is 3.8. F value is 0.205 and the PR is greater than F, that 0.817. Residuals, the degree of freedom 12, sum of the squares 222 and mean square is 18.5. The entire summary of this model is displayed in the R program. In this code, we first create 3 vectors of data for each group. Then we combine them into a single data frame where each row corresponding to the single observation and includes the group that observation belongs to. The value and group will be there in each row. Next, we use the AOV function to run the Anova model. The formula value the versus group specifies that we want to test the effect of the group variable on the value variable. We pass in the data frame using the data parameter. So likewise, we can verify the Anova results in R programming. R programming is very much useful for analyzing the statistical. I hope everyone can understand what is the just the introduction of the Anova. So further we'll see in the next videos how effectively utilize the Anova